Hello, my name is Jon Wills and I'm the Business Development Officer for Worcester Scientific, a sensors company exploiting F-bar nanotechnology in Worcester. Although some of the audience may know us from the Beta Den Tech Accelerator situated in Malvern, where we were part of the cohort 1. My talk today will cover sensors, data, the IoT and the latest endeavours of Worcester Scientific. So let's begin. The demand for sensors is increasing. 5 quintillion bytes of data are produced every day. That's a 5 with 18 zeros, according to Cisco. But how much of that goes unanalysed and unused? The answer, around half. Why am I telling you this? As a sensor manufacturer, I should be happy that the appetite for sensors is growing. The Internet of Things is having a profound effect on the way we live our lives, from intelligent fridges, TVs, watches, phones, cars, and soon it'll be clothes. The inanimate objects we once considered simple, now complex and enmeshed into our lives. At Worcester Scientific, we've begun to ask the question, what for? We've already established around half the sensor data is going unanalysed and unused. Is the embedding of sensors just a marketing stunt designed to shift more consumer goods? That's one to ponder for the rest of the day. Worcester Scientific is doing sensing a little different. Our F-bar sensor platform produces highly sensitive and selective data, elevating it beyond the standard sensor types on offer, meaning that you measure the substance or property you need to at levels previously unattainable without the background interference or cross-reactivities. The desire to automate and make intelligent ordinary items may be a needless pursuit in some industries, but in others, real value can be added. Worcester Scientific is exploring options and analysing markets to identify key processes which can be made smarter and more efficient, and I'd like to share some of those with you now. The first of these applications is the analytical science market. A wide variety of businesses are reliant on taking samples and sending these off to a laboratory for testing, farms and food producers being easy examples to give. This time-consuming and costly process can often hinder the movement of goods and slow down the completion of the processes involved. The instrumentation involved in taking or storing these samples has gone unchanged for decades. The Petri dish I used at school will have been the exact same one you used at school, or maybe yours were glass. But the form and functionality has remained constant. By embedding nanosensors into these specific to target substances in the head of a swab or the base of a Petri dish, the process of analysing food or key components can be vastly improved, offering a solution for rapid testing in farms and factories. Another key area of interest is air quality. What's in the air we're breathing right now? Alongside our sister company Air Spectrum, we have brought 2 indoor air quality and outdoor air quality products to market. Fully conversant with HVAC systems in our offices and buildings, our indoor air quality device accurately records data and shares it to an online platform where building owners or managers can observe and act where necessary. Another system, meanwhile, will monitor your outdoor environment and site boundary, reporting data to an online platform. Once again, building owners can control their environments or the sensors can provide contractors with the data they need to meet Environment Agency and DEFRA guidelines. Embedding sensors to develop IoT-enabled devices and creating networks of air quality monitors isn't the stopping point either. Worcester Scientific has become a member of the DigiRail programme and signed a Memorandum of Understanding with the University of Birmingham and their Rail and Research Education Centre, BCRRE. The purpose of this engagement is to develop a hydrogen sensor system for the UK's first hydrogen train. The sensing of hydrogen is key for the rapidly expanding hydrogen economy, where our hydrogen-specific sensors can be utilised for detecting levels of hydrogen from 0.002% or 20 ppm up to 4% or 40,000 ppm, which, as some of you may know, is the lower explosive limit of hydrogen, so the sensor's kind of void at that level. But it gives you an idea of our range, from small leak detection into safety monitoring. To put those numbers into perspective for you, I recently spoke with a scientist at Spain's hydrogen research facility, who told me that his state-of-the-art laboratory equipment has a lower detection limit of 1% hydrogen. So these sensors are leading edge. So what are the next steps for Worcester Scientific? We are continuing the development of our hydrogen sensors with the DigiRail team, with the hope of testing and trialling the devices in their application. For the air quality, we're able to showcase these two sensor systems, and I would invite anybody to come and talk to me after to learn more about these. If you want to get in contact with Worcester Scientific, please find us on Twitter at Worcester Sci, or on LinkedIn, or online on our website. Thank you very much.